Greetings and welcome to another video. Now in this one I'm going to cover some more practical aspects of UI elements. Now there's another video that focuses more directly on UI. I'm going to go over this program because it's a little bit better of a sort of in the wild type of view of how UI elements are actually used. That and I've got some good practical examples in this code here of how to set values through GUI elements and how to create radio buttons. And so with that, let's just go ahead and see what this does first, and then we will go and look at the code. Now, this is an algorithm I've been working on for generating cave-like dungeons. And so you click on the drop button, and it proceeds to do its little algorithm. Click to convert to dungeon to see where unwalkable, which oddly enough is green, and walkable, which is red. I'm not entirely sure why I put the colors like that. But yeah, the walkable area is the red area, the blocked area is green. And you can place a border around it. You can toggle between your raw data and the dungeon data. You can modify how wide the area is, how high the area is. Oops. With some sanity checks, notice it's not letting me put in. You'll just have to take my word that I'm trying to type in letters right there and nothing's happening. You know, how many things are going to drop, how big the drop size is. You know, so drop size at 3 looks like that. Drop size at 6 looks like that. So on and so forth. And while it's not customizable with these buttons, the location of this drawing area can also be modified by modifying my X offset and Y offset. Okay, so that's what it's doing. Now let's take a little bit closer look here as to how this is actually working. Since I've already got it selected, let's start with the placement of this preview area. Now this visualization area is done by using the graphics.drawTexture command, which is probably the easiest and fastest way of just doing straight up 2D drawing to the screen, but certainly not the way you would want to rely on for a full game. First of all, it is very draw call intensive. If I turn my stats on, we can see that just with this 35 by 35 grid area, I've got 1,248 draw calls going on. Of course, that also includes, you know, my GUI elements here as well. But that's a lot of draw calls there. There they are. Now, if I increase this, you know, more, say to, you know, 55, you can see, you know, now I'm all the way up to 1,948 draw calls. That's expensive. On a PC, it's not going to matter. You can see my frames per second still blazing away at close to 200. But on a mobile device, that's going to be crippling. That's definitely going to be a noticeable slowdown. So it works great for visualization on the PC, not so hot for actual game use. Now, how I actually place this, let me get this back down to a more sane size here, is I use an offset value over here, seen by X offset and Y offset, that determines where I actually start drawing this. Now, so when I determine this point here, I assume everything's at 0, 0, and then I take these offset values and add it in to offset where I'm actually going to be drawing this. So I can, you know, dynamically, you know, adjust, you know, where I want the X offset, you know, where do I want the Y offset. Now, something to keep in mind when you are altering values in the inspector like this during runtime, those altered values will not be saved when you stop the play preview. This is good and bad. It means if you screw something up, all you have to do is stop the preview, start it back up, and the screw up is gone. It can be annoying sometimes when you get that perfect, just absolutely perfect positioning, and you forget to write down your values, and you stop, and it goes away. So it's just kind of a catch-22 there. The key thing is that when you are messing around with these things, I determine that, you know what, my Y offset, I really want it right there, and my X offset, let's bring that over to 95. All right, that looks good. Actually, one of these values, I would have to make sure to go through and write these numbers down. And to that end, I usually have, well, for many other purposes as well, but I generally keep a nice big pad of sticky paper, Post-it notes near my computer. So that way, when I have little notes like this, I can just jot it down real quick, stick it someplace, and when the note's no longer valid, I take it down. But make sure you pay attention to that. And you can see just real quick to bring back the attention to the performance issue. You can see the difference here. My 30 by 30 thing is getting around, let's say, 350 frames per second. But when I change it to 35 by 35, now I drop almost 100 frames per second doing that. And then I make this to a 55. Now I'm down almost 200 frames per second. So don't underestimate the performance that you're going to get from trying to use lots of graphics, draw textures to draw stuff. Okay. So we'll take a look at the code for that in a moment. I want to talk about the layout here. Now, you can see everything's nice and perfectly sort of sized. My buttons are no bigger than necessary. Everything fits together nice and neat this way. Going down vertically, everything is perfectly lined up. That's because I'm using GUI layout. When you're doing the user interface, you've got two approaches when you're using Unity's. You have got GUI and you've got GUI layout. GUI, you manually place everything. You have to place the XY coordinates for everything. It gives you considerable power and placement, but it's also considerably annoying to get things lined up correctly as well. Here I am using the GUI layout, so that way I am allowing Unity to handle all of the sizing and how tall should the box be and how wide should the box be. I'm letting Unity handle almost all of that. I'm not letting it handle it for these text boxes here, which we will see in a moment. And so I've got a horizontal layout running this way, and then I've got a vertical layout running this way. So those are my two layouts we're going to take a look at. And see, I don't think there's really much of anything else to look at on that screen. So let's hop over to Visual Studio. Okay, so this code here is badly written. It is badly formatted. Everything's jarred together. And that's because this was exploratory code. I had a vague idea of the algorithm when I sat down to write this, but I wasn't entirely sure how it was going to work or what the end result was be. And so I just sort of grew this code organically. It's like, oh, let's make a change here. Oh, let's add this. Let's tweak that. Let's put something else in. And honestly, it shows. When you're looking through this code here and how it's organized, it really does show that it was organically grown. Sometimes you've got to do that when you're just really utterly not sure what it is that your end result is going to be. But you, generally speaking, want to try to avoid that. So now that I've almost got this algorithm working, I need to go through and rip it out of this test script file here and get it all prettied up and put in its own proper object and everything. The key thing here is that the key failure, at least if I was looking at this from a production point of view, the key failure is that I've got the UI display code and the actual core algorithm logic completely intermixed. I can't separate them. If the GUI interface elements and the algorithm logic are utterly inseparable from this file. If you want one, you've got to have the other, and that's bad. That means I can't take this to another project and actually use it. So it needs to be refactored. But it's good because it gives us a little better view of how GUI elements and data relate to one another as far as displaying and interacting with one another, which is why I'm showing it in the state that it's in. Okay, so let's take a look first at the GUI method to get an overview here of how everything is being drawn. Actually, let me go ahead and bring this back up so that we can reference back. All right. So, like I said, I'm using GUI layout, and this is how you use it, GUI layout dot. And then with the layout, you have to specify, am I beginning a vertical or a horizontal section? And you can nest them, obviously, like I'm doing here. You can sort of think of this as, I'm saying begin vertical, so I'm saying, you know what, I'm going to define a series of rows. So let's start the series of rows, and here's where I'm actually going to do the first row. Or here's where I'm going to do my first set of columns, I should say. So I'm going to do this begin horizontal, and this begin horizontal corresponds to this row right here. This is my begin horizontal stuff. So we look at this, we have a GUI layout.button drop, GUI layout.button convert to dungeon, GUI layout.button place border. If we come back and look at Unity, indeed, drop, convert to dungeon, place border. All of those show up in the order I appear, and because I am using GUI layouts, it perfectly sizes the button backdrop to this text, which is very useful. If you're just using regular GUIs, GUI.button, you then have to make sure that you are sizing the button correctly when you set the position and the size with the rectangle. Remember, for buttons, they return true or false depending on whether or not they have been clicked this frame. And like most applications, a button is not pressed until you release. So you notice I'm holding down the left mouse button. You can see that drop has been depressed, but nothing's happened. If I drag my mouse off, notice that it went back up. That's standard button behavior. I mean, it's generally what we expect to see from buttons. So that's, standard button behavior there. It doesn't actually trigger that true message until the very first frame that I go down and then up. The first frame that I release my mouse button, that's when that is triggered. And then I do the appropriate code, which we'll take a look at a little bit later. Now, this section right here is the radio buttons. Right here, I can toggle back and forth between, and let's actually do a convert to dungeon so we can see the difference here. So this allows me to toggle back and forth between display dungeon and display my raw data. Now, Unity inherently does not have radio buttons, like you think of on the internet. If you're used to it all with HTML code, you're familiar with these guys. You set up groups, and only one button in a certain group can be checked at any one time. That's not what these are. These are just actually regular old toggle buttons. So if you look in here, you'll see that I'm using toggle. And toggle will return back the value of the button. Has this button been toggled on or off? Again, coming back here, you notice I do have a slight bug here in that I haven't actually put in the sanity checks to prevent the user from toggling off the button. These are just toggle buttons. They're not radio buttons. If I wanted to actually prevent that from happening, I'd have to put in some additional code that says, well, wait a minute, you know what? If both of these are false, that's not good. I need one of these to be, true. But I'm not, oops, didn't mean to do that. Twitchy finger. But they mostly work. So what I do is, I take whatever value it returns, and I say, okay, you know what? If display dungeon, since this is a true-false value, I'm saying if display dungeon is true, then I will say display raw is set to false. And that's what gives me the bouncy thing. So as soon as I set this one to true, that one gets set to false. As soon as I set this one to true, that one gets set to false. And same thing here. I say display raw equals toggle display raw, and then I do the appropriate thing. Now the fix here is actually pretty simple. If I wanted to check this, I would say, okay, well, I just, toggled this off. So I'm going to say if display dungeon, or actually it would just simply be, see here, it's display dungeon and display raw. So in other words, if both of these are set to true, then set display raw to false. However, if I fat finger the keyboard here, display dungeon, not display dungeon, and not display raw, display dungeon equals true. So now here what I'm saying is, okay, well, I have to think about the Boolean logic here. Currently this is false, this is true. If I toggle this off, they will both be false. And so if I check here, and this is going to get just checked in order here. So if I say this, all right, so display dungeon and display raw, not display dungeon, sorry, and not display raw, both of these are set to false. I'm going to turn display dungeon back on because that's the one that I was on. And then likewise, I can come back down here, and strictly speaking, that check there is probably not necessary. Think about it a little bit more. I can say if display raw, oops, we'll just go straight into the check. If not display raw and not display dungeon, and display raw equals true. And we can test this. Stop, restart, and now it won't let me toggle it off. Still can toggle back and forth, but now I just simply can't convert. Make sure we're actually, it's changing properly. And so you can see here, it's, not going to let me toggle it off now. So now I've got a true radio button going on here. Okay, so moving off of the radio buttons, now we're down into the labels and text boxes. So this here is a label. It's a fairly standard label. It's just text that you cannot interact with. You can't change, the user can't change it. There's no prompts to select it or edit it or anything else like that. So it's a label. And those are pretty simple. It's just simply GUI layout.label, what text you want in there, and toss it in. Now the text fields are a little bit more interesting because the text fields have this property called autogrow. And what that is if I take out where I'm overriding the width, and I just do it like this, dungeon width equals GUI layout.text field dungeon width. Oops, forgot to save my code. Save, restart, and X offset. Ta-da! It does this. And that's because when you're using the layouts, it's automatically creating sort of regions when it does these layouts. And so when I did this horizontal stretch, it created a region out that far. So then when I go and do the text fields, it's like, okay, well, nothing else is going to be over here, so I might as well take up the entire room. No, I don't want you to take up the entire room. And so that's where you have to get in with the overrides. And there's a whole set of these things predefined. GUI layout options. If you look it up on the webpage, the scripting reference, you can find those fairly easy. Just do a search for GUI layout option, and it'll give you all the options. You've got a couple of ways of handling it. You can either specify a width, or you can turn auto grow off. So, for example, I could say GUI layout dot expand width false, telling this component, you know what, I don't want you to expand your width. Come back over here, As you can see, that gets me less than desirable results here. It's now going to shrink that text box to however big the input happens to be, which is kind of weird looking in my opinion. I don't really like that very much. I like, having the text box be a little bit larger, which is why I went with, instead of specifying disable expanding width, saying, you know what, I want to manually define what the width is for this particular component. Now, how do we get the information out of those text fields? In other words, how do I go from, oops, if I can not double click, how do I go from saying 55 here, oops, wrong. How do I go from saying 55 here and getting that translated into a width of 55 here? Well, it's a two-step process. First, this is a text field, so therefore you're going to be using strings. And what you do is you pass in a string that says what is its current value. In other words, what do I need to display to the user? If you don't do this, then nothing's going to happen. Also, the text field will return back whatever change was made to the text field in that frame. If you don't do this, it won't change. So if I take out this assignment operator, save, come back over here, stop, run. Notice I can't change it anymore. I can still change my height. I can't change the width because I took out that assignment operator. It's not going to, catch whatever change values was turned in. It's just going to constantly say, okay, you know what? Your value is this, your value is this, your value is this, and it'll never allow it to change. So you've got to make sure you've got that in there. Now there's a few additional considerations you got to keep in mind when you're doing with numbers. A number is not a string. You can't use a string where you expect a number. The string 35 is completely different from the integer 35. So we need to process this. I'm going to go to my process width and height method here. So what I need to do is I need to try to parse the string into an integer. And how you do this, and this goes for all of the different numeric types, is the data type.parse. So if I've got an int, int.parse. A double would be double.parse. A float would be float.parse. So on and so forth. And what it does is that takes a string and attempts to turn it into a number. Now, there's a couple of possibilities that could cause this to go bad. One, you pass in a null string. In other words, I can't actually fully show that because it won't let me, because I programmed in sanity checks against it. But if I was to hit the delete or the backspace key again, I would take out the 3, and at that point I would have a null string. A null string cannot be parsed. It will throw an exception. The other thing that can cause an exception to get thrown is passing in a badly formatted number. For example, if I actually pass in the string to TWO, that's going to get me kicked up a format exception error. It doesn't know how to handle that. And so I've got to try and deal with that. And the basic way of doing that is a try-catch statement. So basically I'm saying the implications behind this is someplace inside this try statement, I have a chance of an error happening. I have a chance that an exception is going to get generated. The system is going to throw an error, and I have got to catch this thrown error. Now, if no errors are thrown, the catch statement will be ignored. The catch statement only triggers if an error is thrown. So if all goes according to plan, it'll parse the width, it'll parse the height. I'll handle my logic here. Do I need to reset my data to take advantage of the new width and height information I just got? If everything goes well fine, all of this will execute, and then we'll skip down here and fall out of the method. However, if either one of these fail, we're going to catch it. Now, there's two forms of the catch statement. One is a catch all, like I have done here. I'm basically saying, I don't care what it is, catch it. And in this particular case, I'm doing this because, well, I know there's only two real errors I can get here, format exception and null string exception. And I don't care what kind of exception it is. I just simply need to reset the string value to my width and height to make sure that I don't have corrupted data or anything. If I did care, what you do is you use a parameter to tell the catch what it is that you want to catch. So let's see here. And I don't remember off the top of my head exactly what the exception is. So, F1. Oh, you can always highlight something and say F1 to get to help page. Or you can also right-click, go to definition, and be able to tell some more information about it this way too. But going back over here, parse string, and I can look this up. Exceptions, argument to null exception, format exception. That's what I was trying to type in. Well, apparently autocomplete is failing me because I should be able to do a format exception. I'm not entirely sure what using statement I am missing to not have my format exception popping up. Namespace system, MS core lib, format exception, system. Okay. That'll be a mystery to solve for a later video, so I'm not entirely sure why. So I shouldn't have to say using system. But maybe I do, due to it being in Unity. Okay, that's what I was missing, using system. So I'm used to not having to put that in. I guess because in console applications, using system I think is automatically put in there for you. So I could say format exception E, and this would only catch a format exception. It would not catch a null string exception. I would then have to put in a catch argument null exception. To be able to catch that one. But again, I do the exact same thing for both of these, so yeah, don't need that. So that is the process of how you deal with a text box. So each frame you have to pass in what value should be in the text box. Each frame the text box will pass out what changes were made to it. So, dungeon width equals GUI layout.text field dungeon width. And then if that's a number, you then have to further process it, like I'm doing here, and trying an int.parse or a float.parse, whatever it is that you need to do it with. And be aware that you need to catch exceptions, because the user could accidentally type in a letter, or the more common thing is trying to backspace out. They'll backspace it out to a null, and that would, mess up the entirety of the script right there. All right, and that covers all of those. Let's see here, process. We were just at the processes. And here I have my int vertical. So at this point, I'm done with GUI layout. Everything is on me now again. And now I've got displaying the raw data and displaying dungeon data. Now, these two use, like I said, graphics.drawTexture, which is why they're in this special if statement here. There's a couple of different passes that the onGUI method gets called on. We've got to make sure that we only do graphics.drawTexture calls on the repaint event. Otherwise, weird things happen. So go to definition. And so all I'm doing here, it's very basic, is I'm creating a rectangle because draw texture, I have to have a rectangle stating where and how big is this. I set my width and my height according to my chunk size, which I have set to 4. At least I believe it's 4 pixel areas. And then I'm iterating over the entirety of the data length. I am converting my index value to an XY coordinate. The specifics on the math on that is a separate video. But I'm just going through my single dimensional array, taking that single dimensional array and converting it into a 2-dimensional coordinate, multiplying those coordinates by my chunk size, because if they're, coordinate 0 would be drawn at 0, coordinate 1 would be drawn at 4, assuming I have a 4 chunk size, a 4 by 4 pixel. 2, I would draw at pixel 8. 3, I would draw at pixel 12, so on and so forth. And then once I have calculated this new position where I want to draw this chunk of graphics memory at, I then call graphics.drawTexture, pass in the position, and pass in what it is that I want to draw. Which I'm saying, okay, you know what? I've got a value inside raw data of I, and that's the texture that I want to display. Now the last part of this that I want to go over, and then we'll wrap up this very lengthy video, and that is the initialization of all of this. There's quite a bit that I've got to initialize to make sure that everything works as intended. To start with, I need to make sure that my strings for my text boxes are properly set up. So I'm going to take the width, height, drop count, and drop size, and call toString on all of those and stuff them into the appropriate string. That primes my text boxes so that way they've got the proper data showing right off from the start. Finally, I'm going to call reset data. No, not refactor. All right, F12, there we go. Reset data is an important one because I need to make sure that my arrays are properly set up. And so reset data basically creates new arrays now and says, okay, raw data, your size width times height, dungeon data, your width times height. And then I go through just to be sure, and I clear all the values inside that memory to 0. Always want to do that. Never, ever, ever assume that everything will be initialized for you. That's a very bad and dangerous habit that you can get into with C#. Because C# does automatically assign default values in a lot of situations. It won't do that in every situation. And so you've got to be very, very sure, especially when dealing with arrays and chunks of memory, that you initialize all of your data properly. And that's what I'm doing here. I'm going through my array of integers and making sure every single value in there is 0. Now, why do I have this out in its own method? This right here could very easily fit right here. And it's only a few lines of code. Well, the key thing here is that I'm going to have to call that multiple times. Anytime I change the width, I have to reset the data. Anytime I change the height, I have to reset the data. And so since this is a piece of code that gets called multiple times and has functionality outside of this start method, that's why I pulled it out and put it into its own method. So you got to keep an eye open for that when you're writing your code. all of a sudden you realize, hey, wait a minute, haven't I done this chunk of code like in 2 other places already? When you realize something like that, you've got a good candidate for pulling that functionality out and making its own method. This way, it's easier to update. If I have to update how I initialize my data, I've got 1 point to go to instead of 2 points to go to. Okay, the next section here is I am checking my texture 2Ds to see whether or not they are null. So my impassable texture, I check if it's null. Well, then I'm going to create it and set it to whatever color happens to be set here. You know, color, impasse color, color, passable color. So whatever those colors are, I will create an array of the appropriate chunk size. So if I've got a 4-pixel chunk, then I will create a 4x4 or 16-pixel color array. I then need to go through and set all of those values, and then finally I can call setPixels, passing in that color array. And then finally apply it. Always got to remember, when you're modifying texture data, always apply it. Always, 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 always. I'm going to do the same thing for passable. I'm going to create an array of colors according to what my chunk size is. Or actually, first I'm going to create the texture with the x, y, the width and height of my chunk size. I'm going to create an array of colors according to that chunk size times chunk size. And then I'm going to go through and initialize every color value in that array to whatever color I need it to be. I'm going to copy that into the video buffer memory by using setPixels, and then apply to push it out to the graphics card. A word of warning. These 2 commands right here are horrifically expensive. You do not, under any circumstances, if you can possibly avoid it, you will want to avoid it. But do not call this in a high repeat loop. Do not do this in update. It will be a massive performance penalty. It is cheaper to do 9,000 draw calls than it is to use setPixels 9,000 times and do a single apply. I've tested this in my code. I'm not entirely sure how Unity has this set up, but setPixels and apply are horrifically expensive operations. Ideally, you do them like I've done them here, once at startup, and then you don't mess with them again while the game's actually running, or any time that you expect real-time performance. Once I'm done with that, I basically do the same thing again with my heat map. I have 10 different levels of heat, transitioning from green to red. So every step I subtract out green and add in red. And that's how I get the shades going from green to red. And see here, that is the setup there. Now, the remainder of the code primarily deals with the algorithm itself, which is not the point of this video, so we're going to leave it alone for now. This video will be available on source control. Did I just say video? This script will be available on source control. Just the script, though. It's just going to be, and I'm probably going to rename it. I'm not entirely sure what I'll rename it to. Probably GUI algorithm demo, just to make it a little bit clearer. All you will need to do to get this script in is import it in as a new asset. So you'll go into Unity. Stop playing. You'll go into Unity, you'll go into Assets, Import New Assets, find where you loaded this, where you downloaded the script to, where you checked out the script to, and add it in, and just drag it onto and drop it onto the main camera. I'm using 16 chunk size. I don't know why I was thinking I was using 4 for some reason. As far as the default values go, you will have to set the colors. The only tricky part to these colors is that when you set them, by default, and actually let me go ahead and just file, save scene, and then remove the component. All you need to do is just drag it onto the camera, and it'll work. But you got to set these 3 colors here. The display texture you do not need to set, but if you want to actually have this work, you need to set this. And you got the key things. You got to change the alpha. It defaults to the alpha being off, meaning fully transparent. And so you've got to make sure that you set that alpha value so that way the colors will actually show up correctly. Oops, and the chunk size defaults to 1, which is probably not a good idea. And so, yeah, set it to 16. And then the other thing that you need to set on this, if you want to look at it, is the conversion rates must be changed. The conversion rate shows from green to red how likely it is to be walkable. You want to leave element 0 at 0. The rest of these you can put at whatever you want. I would recommend at the very least having 90s or higher for elements 5 and higher. But of course, experiment around to see what it is that you want. And I don't actually want to save that change, so I'll leave that alone. All right, well, this video has gone long enough, and so until the next video.